Good morning, everyone. First, a little bit about yesterday. Mondays for me are mostly meetings, but yesterday was all online, trying to communicate with people, trying to figure out where everything goes. It turns out University of Calgary is shutting down, so yeah, we're sort of the central distribution hub for all of the different little pieces of the virus that we've put into bacteria. So we're going to be doing a lot of shipping. I had to pick up 60 pounds of dry ice from our loading dock. Yeah, nothing that makes really great content or entertainment for anyone, but yeah, that's sort of where we are. So last night I did start seed cultures for our next round of growing. We're going to see if we can get papain-like protease to express and be soluble. We're going to try some new non-structural proteins, so that's 4 and 14, and I'll have a little bit about what those guys do. So yeah, let's get started. Alright, here's our media. Now we're going to add 2% ethanol. %. %. Alright, next we have ampicillin, which my cells are immune to. Anti-foam. Anti-foaming agent. Alright, and then this guy is kanamycin. And that's our second antibiotic. Our cells are still immune to that, but we use that one so that we have some redundancy, so we can use normal pop bottles. Pop bottles are great because they're tall and skinny, so we can spin them really, really fast. And then they've also got baffles on the bottom, so they sort of throw the culture media up the sides and get really good aeration. We're going to start the purification today for N protein. This is going to be awesome. A little stuck, but here we go. Let's put these guys in some water. Hold on. Let's get those guys thawing. Alright, so we're just adding the seed culture to get these guys started. So, this is one I prepared last night, so there we go. We're all inoculated to grow 3 liters. Alright, there's our bacterial cells. Get them on a stir plate. Stirring, lower in the ultrasonic disruptor to its right height. Nice. Alright, so this week we're going to be looking at a few different proteins. The first one I want to go over is the one I'll be purifying. This is this little black one. That's N protein. So N protein has 2 sides to it. It has on one side the RNA binding domain, we call that the RBD. And then on the other side we have the C terminal, that's C for carbon. And we'll get into that probably in another video. But we'll be doing just the outside portion. And the reason that's important is that that's the side that an antibody can recognize. So that one's important for immune function. The So that's the one that we're going to be purifying, and then later we'll be working on an ELISA. More on that later. So the other one that we'll be working on is this PP1. We call it PLP here, but this one's responsible for cutting up this big viral polyprotein. Once the RNA goes in, it gets translated into this huge, big, long protein. But to actually activate it, you have to cut it up into pieces. It's sort of like unlocking a truck full of goods, right? You have to unpack it. So that's what PLP does, and it sort of expands everything into its functional bits. So then we're actually growing two more. We're growing non-structural proteins 4 and 14. 14 is responsible for host cell immune evasion, and then 4 is responsible for anchoring to the endoplasmic reticulum. So that's going to be a really cool, it's going to be a cool week. So stay with me. All right. Let's fire up this bad boy. Alright, so this is the ACTA control screen. The ACTA is just a really, really complicated set of pumps and a UV detector. So we've got our UV absorbance, our conductivity, and our pressure here. Once UV comes back to normal, we're going to be done with this little washout. So what I'm doing right now is I'm just washing the lines that suck up the buffer, and this should be about good. Alright, that's A1 washed. Now, we're going to wash my imidazole line. So, set flow rate, set %B, and resume. We're going to wash that out, and you see %B comes up, and imidazole absorbs a little bit of UV, so we're going to measure that. Oops. 24. There we go. Let's wash that out. Now watch this. Whee!
Oh, I know, it's a pupster.
Well, Aesop came to visit me with his human, my human. But he's a little distracted right now. Doggos can still boop. They don't have to social distance at all. You want to hear the most annoying sound in the world? Alright, cool little science experiment before we start freezing these tubes. Everyone knows ethanol doesn't freeze, right? Except in liquid nitrogen. Yeah. In liquid nitrogen? Freaking anything will freeze. It's always weird to think of ice as being warmer than something. I mean, right? Can't do that there. But, you know, especially dry ice being warmer than something, like... These guys are stored at a little bit above the temperature of dry ice, well below the temperature of wet ice. I flash freeze them using liquid nitrogen because it forms smaller ice crystals that do less damage to the cells. Alright, here's our lysate. It's all sonicated and smooth. Everything's been homogenized. Now we're going to take it over to the centrifuge, spin it down really, really fast, and separate all of the solid parts from all the liquid goodies. Morning, baby. Alright, ready? So here is our bacteria juice. That's gonna get sucked up into our machine until there's no more left. That's all gonna get loaded onto one of these guys, and that's our nickel resin. That's our nickel stuck to like a resin, sort of plasticky. All of our protein's gonna stick to that, and then what comes out on this end is gonna have no protein left in it. Well, none of our target protein. Then we're going to wash everything off with imidazole. That's all going to come off and go onto here, which will separate all of the proteins that are left by size, sending them finally to a fractionation block. And everything that comes out is going to be sequentially laid out, and it's all going to be separated by size, with the biggest stuff coming first and the smallest stuff coming last. Alright, so we've started pumping buffer A1. We're just cleaning out the line. Pretty soon it's going to switch over. This little, sort of turntable to switch to pump buffer over our column and just clean out anything that was sitting on there. So down here in the basement, I presume to save power while we're on a skeleton crew, they've turned out half the lights, and the basement has gone from a little bit spooky to actually really ominous. Alright, so we're pumping it across the column. It's going to outlet 1, and you can see there's a lot of something in there that's not unexpected. So we go over here. Yep, we're aspirating, and there it is coming out. Alright, so now that everything's been loaded on, we've washed off a little bit of the extra stuff, and here we have sort of phase 2, where we start loading imidazole on, and you can see almost at once, whoop, we start getting protein off, and that is our first round of purification. That's our nickel affinity. So after that, whoop, the rest of it sort of just gets kicked over to the waste, because we don't need more than those 10 milliliters. Yeah, 10. And the next step is going to be size exclusion chromatography. See that? Alright, so this is that protease, the one that unpacks the rest of the viral polyprotein. You remember how clear it was before? Well, that is our bacteria. True to form, for this particular protein, it took 10 hours to get to this point, so I'm glad I was able to say hi to Violet earlier in the day, because, yeah, I've been here 10 hours. So, we're gonna get this guy tested and see if we can induce protein expression. So, since I can't do that with while holding a camera, I'm gonna turn this off and then let you know what the result is. Alright, so let's open this up. And 871, since I diluted by half, that should be 1.742 at 1640. Nice. Alright, let's get this guy moving. Alright, so this guy is called an ultraspec, or a visible light spectrophotometer. That just shines a little beam of light through our sample and tells you how much of that light made it through, or how much was absorbed. So that is an indirect measure for
how many bacteria are in there, because it's just measuring how much of the light gets waylaid on its way from point A to point B. So once we basically know that somewhere around 1.8 is where we want to be. So now we're going to take our pipette and add 0.5 milliliters of, so half a mil of this guy, which is called IPTG. Don't ask me what it stands for, but it's basically an analog for lactose, the sugar that's in milk, right? What we've done is we've hijacked a metabolic pathway in E. coli, so that when we add this, it binds, makes this whole cascade of molecular signals, and causes our cells to basically stop dividing and start making our protein that we want. So, since again I can't do this one-handed, I'm going to turn it off and let you know when we're done. Alright, there we are. We've got the stuff that I induced earlier, NSPs 4 and 14, and then we also have our PLP. So, close that up. We're at 25 degrees now instead of 37. We're going to spin these a little bit less, and see you guys in 16 hours. So that's another day at CSGID. I'm actually really excited for tomorrow. We're going to see if we got PLP expressed. We're going to see if N protein was purified successfully. We're going to start concentrating that guy down, test how pure it is, and hopefully cut off the histidine tag, that little affinity tag that makes it stick to the column. So yeah, join me tomorrow. Go ahead and share this. I've made everything public. I know that a lot of you have been enjoying this. Check out my YouTube channel. My link's in the bio. And yeah, stay safe out there. Stay safe from viruses. Go skin your knee. Not too bad though, because no, the hospitals won't take you. You don't want to be there.